Hey, I'm Cohen.
And I'm Arpina, and I'm from Armenia.
I'm from Somerset in England. We are studying physics and we're about to have a tutorial on quantum mechanics.
Think about this thing here. I had something that Schrödinger wrote. 1935. And assume you have a cat. And in Schrödinger words, it's a cat that is being penned up in a steel chamber. And it's completely isolated from the rest of the world. You can't touch the cat, the cat doesn't see you. Together with the cat, there is a device, which is a Geiger counter. And together with the Geiger counter, there is a tiny bit of radioactive substance. This tiny bit of substance is so small that during 1 hour, maybe one atom will decay, or maybe not. So you have 50% probabilities that one atom will decay and 50% probability that no atom will decay. This is what you have. The poor cat is penned in there. Now what happens if one atom decays? This is what Schrödinger says. If it decays, the counter tube discharges, and through a relay it releases a hammer which shatters a small flask that contains a poisonous gas. So if you want, this is the situation. You've got your cage, you've got your, well, radioactive substance, small tiny bit, you've got your cat, this is your cat, and if you got a decay from there, there will be, this Geiger counter will just crush a container and some poisonous gas will be free into the pen. If one atom decays, the cat dies. So I want you to build the quantum state of this system. You have to write the wave function of this system. So what are the information that you would look for, that you would like to give me?
If the cat is dead or alive?
Okay, this is the first information that you would like to give me. Is the cat well, dead or alive? Okay, if the cage is closed, you can't see inside. What do you know about the cat? Is it dead or alive? After 1 hour of the experiment.
I don't know.
You don't know. So how would you write its quantum state? Since you don't know.
Yeah, well, the superposition of two.
Yes, exactly. You have no idea what the cat is doing. It's going to be a superposition of those two. So if I write the wave function of the cat, see, that's going to be dead plus alive. Equal probabilities for both of them. You need a normalization constant, because you want the probability of finding your cat either dead or alive to be equal 1. And that's the usual normalization constant. Okay, so this is the state of your cat. Now my question is that all you can tell me? Because I have then a doubt about it. Is the state of the cat completely independent of the state of the atom? You've got an atom in there. That atom can decay or not. So are the two systems completely independent? No, they're not. Why not?
Because if the atom decays, the cat is dead.
Exactly, exactly. So what I should do is to include this bit of information in my wave function. Because in the end, I mean, they're strictly related, so they have to do with each other. How can I put them together in the same wave function? I mean, if you want the wave function of the atom separately from the cat would be decay plus non-decay root 2. But these are completely independent of each other. I want you to build out a state that tells me that if the atoms decay, the cat is dead. If the atoms doesn't decay, the cat is alive. This is how you just do the reasoning to build a quantum state, in this case at least. There are cases that are much more complicated than that, but now this is, if you want, very similar to what you had in last week's problem. and next time we'll go more into these absurdities that you have, because there is one thing that you didn't object to, but by now you know it. This electron has a probability of going through, and that doesn't make any sense. It shouldn't go through this. So this is what we'll discuss next time. How likely it is to go through it, how likely you are to go through a wall, if ever, and the sort of things that actually do not make sense from the point of view of classical physics, at least. Okay. So and then we'll talk about this measurement problem again, because the last two problems we've not discussed them yet.
Okay.
So this is for next time. Right. Thank you very much, guys. I'll send you the list of questions to answer to. Well, actually, I've already sent them.
Yeah.
We're going back to Binny's problems. To the new set of problems. So. Well, it's a lot of work to do. Sorry. But basically, everything is along the lines of this potential well and potential walls, potential steps. The calculations are all of them along these lines. But I suggest you to start early. An early start, because it's a lot of work to do. Okay, thank you very much, guys. Have a nice week.